you.
Yeah, okay. Hi, I'm Tom Tromey. I'm here to talk about Rust debugging. Let's see. I always like to have a slide that explains what I'm going to tell you about so that when I'm telling you about it, you can remember that I told you that I was going to tell you about it. At any time, there's two people on this conference. If you have a question or a comment or something, just jump in, you know. So I'm going to talk a little bit about what the current state of things is in GDB and LLDB and in Dwarf, then sort of what's missing, like some sort of accessible projects that could be worked on, then some more out there like future projects that haven't been looked at really, and then I wrote sample questions, but I don't think I actually wrote any sample questions, so you can ignore that last bit. All right, so for GDB, the current state of Rust debugging in GDB is like there's a Rust expression parser. This parser is like a subset of Rust expressions. It's just a this parser has no relation to any other parser. It's just one that was written from scratch. GDB has Rust-like value and type output. So like when you print a value, it looks like Rust syntax on the output. Or when you print a type, using p-type in GDB, it also looks like Rust source code. The expression parser has a couple of extensions in it to do things that you couldn't normally do in Rust. And to support those extensions, there's also some special code in the Dwarf reader in GDB. So we'll talk a little bit more about Dwarf and the Dwarf extensions and stuff later, but two examples of that are like the GDB Dwarf reader needed special support for Rust enum types. And then the expression, because the expression subset doesn't include matches, if you want to access fields of an enum, you can just type enum value dot the name of the field in the currently active enum branch, if that makes sense.
How do you know? Actually, I have two questions. First of all,
sure.
The Dwarf reader, what is that? That's something that parses Dwarf and like converts it to GDB's internal.
That's correct.
Okay.
Yeah, both the debuggers have a step like that where they, Dwarf is kind of this compressed format that's not super great to work with as like a data format, so they both sort of read it and explode it into data structures that are more natural to use. And so, yeah, so, this enum stuff, GDB understands about it. The Rust compiler writes information about an enum into the Dwarf, and then GDB reads the Dwarf to understand, like, where is the tag field? Is there a tag field? Because you can have univariant enums, or is the tag slot shared with, like the non-zero optimization, is the tag slot shared with some other slot? And if so, which special values mean which enum branch and stuff? That's all described in the Dwarf. So another extension that GDB supports is dissecting trait objects. And this, like if you look on the slide, it says this thing about vtables. We made a little Dwarf extension where a trait object will, a trait object's description in the Dwarf also points to like sort of a stub description of the corresponding vtable. And then that in turn points to the concrete type for which this trait object exists. And what that means is if you have a trait object, you can like print star object, and GDB understands how to find the correct type of the payload in the trait object. So, so it's like nice for debugging. You can be in this spot where you don't really know what this thing you're looking at is, and you can just print it, and GDB will tell you, well, this is actually a pointer to one of these things.
Does it do similar things? But you said currently active enum variant. Did you mean that it'll like read the discriminant to figure that out dynamically?
Yeah, that's right. So when you print an enum value, you know, previously if you used GDB before, like say a lot of this enum work went in, or if, you know, if you printed an enum value, that used to look like kind of like basically a C union in the dwarf. And so you would just get this thing with all the different you know, all the different variants and try to figure it out on your own. But now GDB does that work for you. So it will only print the currently active branch. Yeah. And so all this work is upstream. It's just part of GDB, and GDB uses Bugzilla. You can easily go and find the existing bugs. There's, I think, on the order of 25 or something. You know, anyway. So that's kind of it for GDB. Are there any more questions about it? We can move on. I don't know. All right.
That makes sense.
Okay. So LLDB, it's actually it's roughly in a similar state. It also has its own expression parser. Also, just you know, no relation to any other parser. I actually wrote a second one for LLDB. So this one
In C.
in C++. Yeah, they're both. The GDB one is in Bison, of all things, which I wouldn't do again. So for LLDB, it's just like a recursive descent parser written in C++. It actually implements slightly less of the language than GDB, mostly because I missed a step when I was writing it. So there's no deep reason. So, well, you know, like that's just some detail. There's an LLDB bug, or, you know, a bug in our LLDB tracker about the missing bits. Like for instance, the vtable thing I didn't implement. It also has Rust-like value and type output. Its Dwarf reader also understands the stuff that needed to be done for enums. You know, that's something I call out because it's something that's in Dwarf. Like Dwarf has this whole thing about variant types and all this stuff, but no compiler ever emitted it and no debugger ever read it until we needed it for Rust. So it's like a special thing. You can see there's a link to the repository. It's in rust-lang nursery. However, upstream LLVM is moving to this mono repo, and so Rust is following. I think there's a PR that's active right now, and when that happens, our LLDB will be moving to wherever this mono repo is.
Oh, so what does that mean? Like, so you mean it'll go in? Is this part of the LLVM project?
No, it's not. So we will have our, you know, we have our own fork of LLVM in somewhere, rust-lang, and basically that will now contain LLDB.
Oh, I see.
You know,
Okay.
previously we had because of the way LLDB works, you need LLVM and LLDB and Clang actually all in the same tree to build it. So we were doing that with submodules in the normal build. But now with the mono repo, we'll have one repository for all of those, but probably also still our own fork in rust-lang. None of the Rust LLDB work is upstream at us upstream's request. I asked about this. There's some links on if you go to the rust-lang nursery LLDB wiki, there's a link to a discussion. If you read around in that email thread or in that month, there's just some discussion about that. LLDB recently went through this thing where they removed all the other language plugins due to lack of maintenance. And so they didn't want to accept any new ones. So none of this is upstream. And LLDB has a plugin architecture where you can write plugins as shared libraries or something. However, that doesn't work for language support. So we had to fork the whole thing. LLDB is built for macOS as part of the Rust build. So, and it's available through rust-up as the LLDB preview package.
So the recommendation effectively is that Mac uses LLDB and everybody else uses, well, actually I should just say Unix uses GDB. I don't know what the Windows.
Yeah, we'll get to that. There's no answer there, but yes, that's kind of the recommendation. At the time when I did this, the issue I had was I wasn't sure how I wanted to solve this problem of LLDB has a Python dependency, and I wasn't sure how I wanted to deal with that on Linux. And so on Mac OS, that was reasonably easy to solve. We can just rely on the system one. But the Linux world is hairier in this regard. Since then, I feel like I came to an okay solution, and I'll talk about that a little later. So it could be, we could ship LLDB everywhere. My experience, though, is GUB generally works better on Linux. And I know other people disagree with that, but okay. So Dwarf. Dwarf, for people who don't know, Dwarf is sort of the standard way that compilers generate debugging information that debuggers read. It's a debugging format, and it's prevalent in it's the debugging format on Mac OS and Linux. It's a multi-language and extensible format. And the main part that describes types and things like that is also extensible. It's like this tree structured thing where it's got tags and attributes, and you can actually invent to a certain extent your own tags and your own attributes. And debuggers normally are expected to ignore anything they don't understand. So you can kind of go nuts in there if you need to. The Dwarf standard, there's the URL. If you want to go, you can go download the standard and you can see the open bugs. Dwarf is mostly good enough for Rust's purposes. So my overall philosophy when, sort of changing the Dwarf output is to reuse existing Dwarf constructs, even if, say, the names don't exactly line up, or even if the semantics are slightly off. Now, there are some things that that require Dwarf extensions. So we have a few Dwarf extensions that that the Rust compiler emits and that the debuggers understand that are not in the Dwarf standard. One was that vtable thing that required an extension. I feel like there's another one. I'm not remembering what it was. Anyway, they're documented in the debuggers, like in comments or in LLVM in comments. And I think I submitted 1 or 2 Dwarf standard bug reports asking for some changes. Now, some things will require bigger changes. So traits, which I think I have a slide all about how to represent traits in Dwarf, require a bigger change. And there are some things that don't rise to the level of it would be cleaner if we changed Dwarf or added some extension. But in the meantime, we have these heuristics or workarounds that work reasonably well. So I haven't seen the need. So for instance, Dwarf provides no way to differentiate between structs and tuples. What the Rust compiler does is emits fields with names like __0, and then the debuggers look for a sequence of such field names, which is kind of ugly. If you remove the underscores, it might be better because it would remove the ambiguity. So that might be a possibility. It didn't seem super vital,
Yeah, those underscores are something the user types. Like the debugger doesn't know that they're like
The
artificial.
debugger does know now. So I
Oh,
feel
okay.
like, yeah, I feel like those were probably added. I didn't do the archaeology, but I feel like those were probably added because before the debuggers had Rust support, if you wanted to extract the value of a field, you needed to type it into like GDB, and GDB would say, well, x.0 is a syntax error, whereas x.__0 is fine. Does that make sense? So, but now the debuggers know, and so in GDB, like because it has this Rust parser, you can type print x.0, and it knows, oh, you're doing a tuple member access, and does the right thing.
Okay.
Yeah. Okay. So that's like the state of Dwarf. So, pretty good. Some extensions needed. Yes. Okay. Next, what's missing? We're going to just go through. There's a bunch of slides about things that are missing. And these are basically the kind of larger projects I was planning to tackle over the next year, but am not now. One is shipping GDB in Rust up. There's actually a PR. However, the PR, I don't know, I messed something up because it doesn't build it doesn't actually build GDB in automation. So that required some debugging. However, I'm not going to do that debugging because I think the basic reason is Alex didn't like that we're stuffing everything into the Rust build, which makes sense if you think about it. And also, maybe we're pretty close to our time budget for these builds already. So that required, actually shipping GDB requires some kind of change to like the Rust up delivery system so that GDB could be built as its own entity, and then the artifacts that are created that way can be stuck into Rust up without requiring it to be part of one giant Rust build. Now, the reason to ship, however, this PR that exists is still useful because to look at, because the main issue with things like GDB is setting up their dependencies. Remember with the LLDB thing I was talking about, shipping on Linux is tricky because of a Python dependency, and that's true for GDB as well. So my thought there was we can rely on the least common denominator, which is Python 2.7. Most of the distros ship it. And then what I did for GDB was like LLDB or like LLVM, we have our own fork of GDB. This is, and I'll talk about this in a little more in a minute to make it really clear what this means, but we'll have our own fork that has where we import stock upstream GDBs and apply a few patches, and that's the one that we build and ship through RustUp. And one of those patches is a change to have a driver that actually runs GDB, and the driver will check for the existence of the correct version of Python and tell you, hey, you didn't install Python 2.7, please install it however you do that for your distro. And the reason for that is most dependencies can be statically linked, but I think statically linking Python is probably a mistake because it's not impossible or maybe even unusual to want to write a Python script that loads a shared library that depends on Python itself. So for example, I have some GDB scripts that do that. So most things in this build, like in the PR, it statically links most dependencies except for Python. Now, why do this? The reason to do it is so that it's easier to make a compiler change to change the debug info, and then immediately ship debuggers that can understand it. And so that way we don't have this problem where we're reluctant to turn on new debug info features for fear of breaking things. We could just immediately ship everything working, you know. And sort of my vision for this fork of GDB was to treat it a lot like we treat rust-lldb, where most changes, anything not like truly Rust specific, like in this case, that funny little wrapper program, most changes should go upstream first, or at least be in the process of being upstreamed before they get stuck into the Rust tree. And the Rust tree would be primarily about delivering things to users before, you know, actual upstream releases. GDB only releases every 6 months. So, you know, it's a really different cadence. Okay, does that make sense?
Yeah, so basically the recommended way to run GDB with Rust would be to install it via rustup, just like LLDB, if we did all these changes.
That's right. And if you look, like, there's another part of this GDB PR that's salvageable. In fact, maybe I should try to push it in. Well, I don't know. It's not ready. But if you look at, like, there's these little wrapper scripts, rust-lldb and rust-gdb. And what they do is they run LLDB or GDB with some special arguments to make sure that, like, the Rust specific Python code is found properly. The LLDB script, like for Mac OS, has a little hack in it where if you've installed the LLDB preview, it prefers that. And the idea would be to do the same for Rust, the Rust GDB script. And this PR has a patch for that can be extracted or whatever. So
might it make sense to error out, like, because it's sort of a suboptimal, questionable experience otherwise?
You know, eventually, I think that's, I think that would make sense. In the meantime, I'm not so sure, just because you can kind of limp along, and also we haven't solved the problem of, like, you can run the rust-lldb script on Linux, but we don't ship for Linux. So, you know.
Okay, I see. Yeah.
Yeah. So, okay. So that's GDB and rustup. Still valuable to do, but requires this rustup / infrastructure groundwork first. That I actually don't know the state of that. Alex might. Okay, next. All right. Debug on Mac OS. There are these features called SIP, which system integrity protection, I think. Basically, it prevents processes from using the ptrace system call. And processes that want to use it have to be code signed in a certain way. And the certificate or whatever that you use to sign it has to be trusted on your machine. Now, what that means is debuggers out of the box don't work. Now, you can sign these programs. However, to sign them and have it work where the user installs the program and it just works, you have to get an official certificate, like through some Mac, you know, through some Apple process. I was hoping we could work around this by relying on users that already have, like, the LLDB debug server installed. In fact, that's what we do today, which is not very ideal. Not everyone wants to install Xcode. So to fix it in a real way, what we need to do is sign up with Apple and get the special keys that we need to do the signing in automation. However, I looked into maybe getting Mozilla to do this, because Mozilla already does this for its, you know, products it ships. So I talked to someone at Mozilla, but it sounded to me, my understanding of the outcome is that Mozilla can't. We are at the maximum or near the maximum number of things we're allowed to sign with the keys that we currently have. So maybe Mozilla could get more keys? I don't actually know. Otherwise, I think maybe the route forward is that there has to be a Rust legal entity that can get these keys through Apple and manage them itself. So this is a tricky problem. It's not really a technical problem at all. Once you have the key, it's kind of like making sure the build server has it and backing out a CMake patch. I mean, you know, that part's not too hard, but you know, so unsolved problem, and the impact of this problem is pretty big. Like you either have to install Xcode for LLDB to work, or it just doesn't work. So on Mac OS. Now, if we had such a key, we could also sign GDB and ship GDB for people who like that. I don't know. But yeah. Okay. Any questions about this one?
No questions, but good to know. That's definitely an annoying thorny problem.
Yes, it's terrible. There's a this is discussed in a bug in our LLDB repo, so you can look through there for a little bit of information. So okay, something that's totally missing. This should have been in the future stuff section. Maybe is Windows is a complete unknown. I don't really know anything about Windows. Windows has its own debugging format, PDB. There is some support in LLVM for emitting PDB. However, what is not known to me is how well does it handle the things that are part of Rust but not part of C++. Like a really good example would be going back to the Dwarf stuff. How would we describe enums, Rust enums to PDB? Can it even be done? So I don't know the answer. That's something to research. Yeah, so it's just a big blank spot.
Yeah, okay.
Yeah, okay. Remember I talked about like Dwarf and what things are missing or what's needed. So I wanted to do a little bit more about traits because it kind of shows some stuff about how to actually implement one of these projects. So currently, Rust traits are not emitted in Dwarf at all. And the impact of this is that like a really typical bug report to get, I think there's at least, I'm sure it's open for GDB and LLDB, but I feel like there's been several dupes over time. A really typical bug report is I wanted to call a method, print x.method, and it didn't work. Well, the reason it didn't work is that method is implemented via a trait, as opposed to impl type. And that information is just not there. Like some of it is there, but there's no association between like the type of X and how to find some route through the debug info to find the methods, that are implemented on it via traits. Okay. So Dwarf does have this notion of like interface types. It was added for Java, I think. So my idea was to reuse this idea. So you can say, well, this class, this type implements these interfaces. And then each interface would be, each trait would be like an interface type.
One second. Are we talking specifically about like DIN trait object sort of things, or do you mean?
No, we're just talking about traits in general. Yeah.
Okay.
Like, like one of the classic bugs is that one, printing a method, like trying to call a method. But another classic one is you can't implement operator overloading in the debugger without knowing what traits a type implements. So, so the idea would be a trait, Dwarf only deals with concrete things. It doesn't deal with like generic things. So like in C++, it only describes template instantiations, not the templates themselves. And the same would be true for Rust. So the idea would be a given implementation, an implementation of a trait for a type would be one of these interface, DW tag interface type or whatever. And then the type for which it's implemented, right? Like you implemented it for I32. The description for I32 would say, hey, I implement all these different interfaces, and it would have pointers to those interfaces in the dwarf. And then that way a debugger could say, aha, print x.method. Well, x has type I32. I can go look that up in the dwarf. Oh, here's all the interfaces it implements. I can go search through all of those to find the method to call. So that's how that would work. Now that requires first of all, that requires a dwarf extension. If you go and read the dwarf standard, you'll see that interfaces are only really defined for structure types, structures and classes, not for any type, but Rust needs them for any type. Now that's exactly the kind of thing where it's totally fine to just emit dwarf that does that. Debuggers are expected to skip things they don't understand, and they would certainly just ignore those attributes. So that's safe to just do, but it's the kind of thing where, because LLVM does not emit interface types at all, you need to implement this in LLVM and get sign off from the LLVM debug maintainers that it's a good idea. So, you think, well, I should file a dwarf bug report, but if you look at the if you look at this slide, it's like that's the last thing you should do, because normally what you want to do is implement the entire thing so that any problems in the process can be caught before you try to standardize this. Now, the LLVM maintainers have been pretty good about this. So it's not like a giant problem or some complicated negotiation. They're usually just like, yeah, whatever, in my experience. But still, it has to be done. So you get all this stuff into LLVM to emit interfaces and describe them and associate them with types, which is slightly tricky given how LLVM happens to work in this area, but it's not impossible. Then the way I do these projects is usually what I actually do is I do this end to end. I do all the patches first before submitting anything to make sure it actually works. But you still want to stage how you land things. So after you land the LLVM changes, then you land the debugger changes. So you update the debuggers. Like in a case like this, you'd want to update the dwarf readers to understand the new attributes and to change like the data types that the debugger operates with, and then update the expression evaluators to know how to do this method lookup.
Yeah, but before you, I have a basic question.
Sure.
I don't know the answer, but
yeah,
we don't directly emit dwarf, right? So the reason we have to change LLVM is that we're emitting some LLVM intermediary.
Oh yeah, that's right.
Converted to dwarf.
Yes, LLVM has this. There's this whole thing called DI builders, debug info builders, and that's the primary thing that Rust calls into. If you look at like the Rust LLVM API that's in the tree, like, is it called Rust Wrapper? I feel like I have it. rustwrapper.cpp, and there's some file with the funny name ffi.rs, like in librustc codegen LLVM. Basically what you do is, yes, this is a kind of metadata that you construct and it just kind of hand off to LLVM and ignore. So the Rust, there's this part of the Rust compiler that takes like types. It has the Rust compiler notion of a type, and it says, well, like for this type, I call these LLVM debug info builder methods to construct the representation of this type, Yeah.
When you do propose the LLVM change, I guess you would say what Dwarf gets converted into. Would you also talk about what like PDB at that time, or is that usually left off?
Well, you can, now like when I did this for enums, I just didn't, because I don't know what PDB to emit. I know absolutely nothing about that. And my impression was that in LLVM, that is not required because no one even mentioned it. So, I think, I don't know, the impression I was left with is that the PDB stuff is relatively immature. And so it's not like something that they require when you change debug info builder stuff. So, yeah. That surprised me a little. I expected some kind of pushback. So maybe that's something that will change in the future. I really couldn't say. So yeah, if you do know stuff about PDB, of course, those kind of things would be good to do, But so anyway, so we're at the stage where you update the debuggers for, to understand this stuff. And, you can punt on that a little if you need to or whatever. Like I pictured probably trying to implement the method calls, but not operator overloading at first. Just I'm trying to make the problem a little simpler. And also because in my experience, people actually report bugs about method calls, but nobody has ever reported a bug about operator overloading. Once the debugger changes land, then you can go and update the Rust compiler and change it to actually emit this new information. Or more precisely, now you can land the change. It's best to write everything first so that it actually works end to end. Now, and this is the step where, see, if we had both debuggers in rust-up, this would be much more seamless because you could land the debugger changes and then land the Rust compiler change, and people on nightly, when they updated, everything would keep working. Or they would just have immediate access to the new features. Like in this case, the debuggers would, old debuggers would still work fine because they would just ignore the extension. But there are other cases maybe where you emit something, like the enum changes were more in a quandary where if you change the debug output, old debuggers will just stop working. But on the other hand, it fixed the other bugs in the old debuggers. So.
Yeah. Okay.
Yeah.
This seems like a reason also to, if we can get to the point where we say you must use the rust-up.
Yeah, exactly. That's right. That would be preferable because it would let us control our own destiny a little better. Then, but that said, like my view is generally it's better to work with upstream. So I like to try to get things into, like the last step here, file a Dwarf bug with an explanation, Dwarf is a pretty opaque process. So, like you'll file a bug and it's not like GitHub where you file a bug and it's just there and you can comment on it. You file a bug and then a few weeks later, someone emails you and says, thanks, we've accepted your bug. And now it's like a page on a website that's read only. So it's kind of a weird thing, but it's still good to kind of close the loop, or like, GDB patches should go into GDB, and I tried to get the LLDB patches into LLDB, but like and some did go in, right? Like any kind of bug fixes. But my idea is that not to just use this ability to sort of just go off in some new direction, but to continue to work with other existing projects. Anyway, so this process that I've kind of outlined here is the typical process for a big debug info change. And it's not uncommon to do multiple passes through it, where you write some changes and then you have to go back and do things again, like maybe the LLVM review wanted API changes, so then you have to tweak LLVM and the compiler again. Or maybe the LLVM review wanted the Dwarf to be written differently, so then you have to change the debuggers again. So it's not too unusual to have to repeat all this. And it's also, my experience with it was a little bit bad because I feel like I was doing one of these multiple pass things and Rust upgraded LLVM and then everything had to be forward ported. I don't know. That stuff gets to be kind of nightmarish. Okay. Still on things that are missing. There's this open bug about macro stepping, where the question is like, what is the location you emit for a macro expansion? You have multiple choices. You can emit a location of the invocation of the macro. You can emit the location of the definition of the macro. Or if you have a really complicated macro, you can even emit locations for the contents of the macro, or like the arguments, some of them or maybe all of them. So there's this RFC about it. And I think currently there's a flag, but the flag is kind of global, so it's not really good. And so the idea is to let macros decide what to do by having some kind of attribute that lets them tell the compiler where line markers should be. And what that affects is where you can set breakpoints and what happens when you step. So you're stepping through the code, and does it jump into some thing over here, or does it, like for, say, a simple case, the print line macro should just be like a function call. You step onto that line of source, and then the next time you hit next, it goes to the next line of source, and you don't try to go off into wherever print line the macro was defined. But other ones may be different. This is one that, this is a debugging bug that can be done entirely in the Rust compiler. Yeah, what's up? Oh, I thought someone was going to say something. All right.
Oh, yeah, no. Sorry, I didn't realize that my unmuting you automatically tells you something. Yeah, no, I was actually going to ask you about debugging macros. Now, you're writing a macro. How do you actually debug it?
Yeah, that's a whole different thing. Like so yes, I don't know. GDB or LLDB don't really try to deal with that because they don't have nearly enough information.
Do you mean debugging macro expansion?
No, well, you're writing a brand new macro. You've made it. You're trying to test and see if it's doing what you expect it to do. And, you need to debug it in some way. I'm thinking about procedural macros, not what's the other type. My brain just stopped working.
Oh. You mean like you want to step through the procedural macro as it executes?
Exactly. So I can see exactly what's going on.
That's a very interesting question.
Yeah, and I'm also thinking about where you're using another procedural macro inside of a different macro. For example, you've written your procedural macro inside there. You've got a vec state, vec macro or a print line or something else. So now you effectively have a whole stack of execution frames or contexts or whatever you want to call them.
Yeah.
Does that make sense?
It does.
It's probably as much a Rusty problem, I would imagine, a cargo problem. In other words, we are the ones who invoke that code. So you probably could even do it today just by running rustc and like GDB, and setting breakpoints appropriately. But
you could. That would require you to know a lot about.
Yeah, you'd have to do a lot of fancy dash.
Yeah, I think this is, yes. I have not looked at this problem. I consider it kind of a separate problem, but it's definitely something that needs to be solved. Like, my experience with C++ is like you can write these hairy const expr things that are run at compile time, you know, whole functions and stuff. And how do you debug those? There's no way. Well, there should be a way, because you're writing code and it's going to have bugs and it's tricky to get in there, you know. And I think Rust.
That's exactly what I was thinking about, because you know,
Yeah.
you look at anything with like Boost and their crazy nuttiness of template metaprogramming.
Yeah.
You get one thing wrong with the template, and the compiler, you know, it hits the point where it had 10,000 errors, and it says, nope, I'm just not going to go continue compiling.
Yeah.
And you find that your one template, and you change that one tiny thing, and all of a sudden everything works.
Yeah. Yeah.
That's not how it should be.
Yeah. Well, I think these are things that, I mean, they're good ideas. There's something that need to be done either in the compiler or by some other program that reuses the same machinery that the compiler uses. You know, but it's sort of out of scope of what I was doing.
So I just wanted to point out that it's 10:50.
Yes.
I actually have to go at 11, and I think when I go, the Zoom thing gets canceled.
Yeah. I have two more things to talk about, and then we're done.
Okay, I have a question also.
Yeah, go ahead.
I realized I forgot to raise. It sort of relates to the trait dispatching thing. One of the things I would like to at some point do in rustc is to generate one copy of a function, like take what would be multiple monomorphized functions and collapse them into one bit of generated code.
Yeah.
Is there anything like that in Dwarf today?
No.
Swift, I know, does this, but they probably just don't use Dwarf for that. Like, I don't.
Yeah, there's nothing. There is nothing for that. And actually, there's another thing in Rust that requires. This is something else I just remembered, which is if the compiler chooses to emit functions with some like kind of change to the calling convention, you know, Dwarf relies on debuggers to know some stuff about the platform ABI, but like Rust doesn't always do that, right? Like suppose you call a function with a tuple, but the function destructures the tuple. Rust might choose to destructure the tuple at call time, and that is something that you would have to be able to tell the Dwarf, hey, this function, you know, the type of this function is this thing, but the effective calling convention is this other thing, and there's no way to do that either.
I see. Okay.
Yeah. So yeah, you may need more extensions. Yeah. Stuff for the future. Michael Walrester has been talking about changing Rust namemangling, which I think is a very good idea. But to really do that, you need to write new demanglers. One has to go in this thing called libiberty, which is shared by GCC and GDB and the bin util, you know, the GNU bin utils, but it's in the GCC source tree. That's where it's canonically maintained. So you'd have to write a new Rust demangler there. And then LLDB also has a demangler, or maybe it's in LLVM now. Things changed there, and I didn't really follow what was going on. So you need to write new ones and land them. The GCC one is particularly tricky, maybe because at least the C++ one was written, first of all, it's all pure C code, which is a little harder to deal with. And it was written in this style where it can optionally do no allocation so that it can be used from signal handlers. So it's like super, you know, maybe you could just skip that part. I don't know. Okay. So that's one thing that needs to be done in the future. And another one is this idea comes up a lot about instead of having the debuggers implement their own sort of half-assed expression parsers, why not just reuse the Rust compiler? And that's a good idea. One way it's a good idea is that the debuggers, by and large, don't try to implement type inference. It's just too hard. So it means that when you're typing in the debugger, sometimes you need to be much more explicit than you would normally need to be in your actual Rust source code. You know, like there's this sort of principle that the ideal for a debugger would be you could copy a piece of, like say, an expression from your source, paste it into the debugger, and it would evaluate it and get the same answer. But without all the features of the compiler, like type inference, that can't reasonably be done. So reusing the compiler's parser is certainly doable. It's a large project. You still need some kind of bridge to the debugger because the debugger is the only thing that has access to memory. So they need to communicate. Now both LLDB and GDB do have features like this. LLDB uses Clang to compile code to JIT into the inferior, and GDB can do that with GCC as well. So it could be done. However, there's also this issue where both of these, both of the debugger's expression evaluators implement both a superset and a subset, and a subset and a superset of Rust. So they implement just the expression language, but they also add some extensions. Like GDB has this thing called convenience variables, and LLDB has some similar kind of things. But there's also some other extensions for, like, you know, in Rust, you declare what you're going to use in the file that you're doing, like which crates you might refer to. But in debuggers, it's convenient to just be able to refer to anything anywhere at any time. So like GDB has an extension to let you do that. So if you're going to take this route, you not only need to do this bridge, but you also may have to add some mode to let the compiler understand some extensions.
I think,
All right.
yeah. I have to wrap it up, but I think
that's all.
All I was going to say about that is that probably I'm hoping that the outcome of this, like WG grammar, which would hopefully be like a canonical Rust grammar, you know, described in some form that we can generate, may allow us to generate parsers, you know, and subset and superset them without actually needing to share code per se.
Well, the issue, yeah, like, but see, like with the type inference, it's not just about the parsing, but also about some of the semantic analysis.
Yeah.
Yeah. So.
Well, we'll see. That's a very interesting question, but this is a good.
Yeah.
Okay.
Yes.
I have thoughts.
So I hope this was useful. You know, I wasn't really sure where to aim it all, but
I thought it was useful.
Okay, good. And you can reach out to me with, you know, questions or whatever. I'm happy to help. I'm going to be still working on GDB, so I can certainly help there. So.
Yeah, actually, it'd be good. Well, we should make sure we have your, like, how to contact you.
Yeah,
but
sure.
I guess there's always GitHub.
I'll stick it on the slide.
Sounds good. Thanks, Tom.
Yep, cool. Thank you very much.
Thank you.
Yeah, all right. Talk to you later.
Goodbye.
See ya. Thanks.